Okay, three more to do with quadratic formula. So again, on this one, I need to get it equal to 0 before I can start. So what I'm going to do is add 5 to both sides. That'll leave me with 8a squared plus 6a plus 5 is equal to 0. A is 8, B is 6, and C is 5. So A is equal to the opposite of B plus or minus the square root of B squared minus 4AC, it's a 5, all over 2 times A. So I'm going to go to my calculator, calculate the discriminant. I have B squared minus 4AC. Oh, that's a problem. So I'm not going to be able to get a solution for this because 120, it's not 128, it's negative 124, is going to be a non-real calculation. So we're not going to have any real zeros. So it's negative 6 plus or minus the square root of negative 124 over 16. But that's going to be a no solution. So we can see what that looks like in the calculator. And I actually don't want to graph it as a relation. I want to graph it as a function. Okay, so I'm going to graph 8x squared plus 6x plus 5, and we see that we don't have any x-intercepts. Okay, this one's a little bit tricky because when I add 2 to both sides, I actually have to combine like terms. So I have b squared minus 4b minus 12 is equal to 0, with a being 1 again, b being negative 4, and c being negative 12. Okay, let me make sure that's clear here that that's a negative 12. Okay. So b is the variable, is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Be very careful when you're typing in your discriminant into the calculator. Because we have that negative 4 squared minus 4ac. Can't even see what I'm doing. Did I do it right? No. Okay, so b squared minus 4ac, 64. Awesome. So negative 4 becomes a positive 4. 64, 2 times 1 is 2. Square root of 64 is 8. So I have 4 plus 8 divided by 2 and 4 minus 8 divided by 2. 4 plus 8 is 12 divided by 2 is 6. And 4 minus 8 is negative 4 divided by 2 is negative 2. Okay, last one. There's all kinds of stuff wrong with this that we need to fix before we can use quadratic formula. We've got to be equal to 0. So we're going to subtract 6a from both sides, and we're also going to add 3 to both sides to get this equal to 0. So we have 3a squared minus 6a plus 3 is equal to 0. So to fill in my formula, I have the variable a again. So a is equal to the opposite of b. Oh, I didn't do this. A is 3, b is negative 6, and c is also 3. Okay, so the opposite, and it's already negative 6. Plus or minus the square root. Don't forget your parentheses around your b. Minus 4ac all over 2a. Oh. I don't know why I made that square root so long because I'm going to use my calculator. Okay. So I am calculating negative 6 squared minus 4 times 3 times 3. I got 0. The fun thing about getting 0 when you have a discriminant of 0 is that you're only going to get one solution, because the square root of 0 is 0, and 6 plus 0 and 6 minus 0 are the same number. Adding 0 and subtracting 0 doesn't do anything. So 6 divided by 6 is 1. We only have one solution. So let's look at let's see what that looks like in the calculator on the graph. So I have 3x squared minus 6x plus 3. I see that I just touch right there at 1. I don't actually go through and cross at 1. It's just a little bounce. Match each graph with its quadratic function in vertex form. I'll be able to see everything at one time so I don't have to scroll around. All right, that's better. All right, so from vertex form, A is stretch, shrink, flip. H, left and right. K, up and down. So I'm going to identify my vertices on all of these. So this vertex is 2, 1, meaning I went right 2, up 1. This one is -2, +3, meaning I went left 2 and up 3. This one's just up, so that's at 0, 3. But I do have it facing down parabola, so that's like super easy. I'm just going to match that right away. That's B because of the negative. This one looks wider, and the vertex is over at -4, 0, which means I went to the left. Okay, here we go. Wider, 4 to the left. Left 2, up 3. That would be this one. And right 2, up 1, right 2, up 1. Okay. Easy peasy. Now, what you could do is just graph these all in your calculator and match it, but that takes a lot of time. If you know your transformations, it's really fast. Last section, use the discriminant. Discriminant is b squared minus 4ac. A, B, C. A, B, C. A, B, C. So if I calculate b squared minus 4ac, b squared minus 4ac, b squared minus 4ac. I want to see which one of these is positive, which one's negative, and which one's 0, because that's going to tell me which graph I have. Okay, first one, b squared minus 4ac, 0. That means I have one solution. So A has to be 24 because it just touches. Okay, b squared minus 4ac. Oops. What am I doing? Is that right? Yeah. Negative. No solution. This is 0. This was negative. So no solution will be 23 because there's no x-intercepts. Okay, so 25 should be C, but let's just check. So they should have 2 solutions on this one. Now, we have to do the whole quadratic formula to see what the solutions are, but let's just double check here. -3 squared minus 4 times is 9. 153